Chapter 4, Lesson 3 is finding the new dimensions, perimeter, and area when given a scale factor. A few of the vocabulary words that we need to note are dimensions. A dimension is a measurement of length in one direction. We typically see the length, the width, and the height. The area is the flat figure, and it's the number of square units that can be contained within. We have found the area of rectangles up to this point. Later on, we will be finding the area of triangles and other figures as well. We will still use the length, width, and height. The perimeter is the total distance around the edge of the figure. For example, you might see the perimeter of a window. You might have the perimeter, which is the picture frame. There are various other examples of perimeters of figures. What examples do you have? I came up with one more, the fence line around the yard. You could even consider the line around the pool. I'm sure there's many, many more that we're not thinking of right now. When we talked about finding the changes in dimensions, we are going to be looking at the perimeter changes, area changes, and calculating the scale factor given the old and the new. For perimeter changes, if the dimension of a shape are multiplied by a number, this number being multiplied is called the scale factor. Then the perimeter will also be multiplied by the same number, the scale factor. It's a lot of words. So to see what it looks like in an equation, you see the old perimeter times the scale factor will equal the new perimeter. In mathematics terms, we use the perimeter times the scale factor, which equals the perimeter prime. The apostrophe is just to note that is the new shape. Let's look at number 1. Number 1 says suppose the side lengths of the parallelogram are multiplied by 3. What will be the new perimeter? Well, they didn't give me the perimeter, so I guess I need to find the perimeter of this parallelogram. To find the perimeter of any shape, you just add up all the sides. I have 4 plus 3 is 7, 7 plus 4 is 11, and 11 plus 3 is 14. I can prove it by saying it's 4 plus 4 is 8. That's my top and my bottom. I have the left plus the right, which is 3 plus 3 equals 6. 8 plus 6 equals 14. 14 is the original perimeter. I am going to take 14 times the scale factor of 3 and get the new perimeter of 42. Does anybody have any questions at this point? Let's see if you can do number 2 by yourself. Let's take a look at number 3. I know it's already been worked for you, but if you read it, if the side length of the triangle is multiplied by 1/2, then what is the new perimeter of the triangle? Well, we do need to find the original perimeter of the triangle given. You just add up all the sides. We did 3 plus 3 plus 2. 3 plus 3 equals 6. Plus 2 equals 8. Therefore, my original perimeter times the scale factor of 1/2. I know that 1/2 of 8 equals 4 units. I use the word units because it does not give us the type of measurement, whether it be inches, centimeters, feet, or yards. Do you have any questions at this time? Let's see if you can do number 4 by yourself. Did you get 12 feet? Number 4 gave us the original perimeter of 24 feet, and all we had to do was multiply it by a half. Anytime they cut the sides by a number, that is also the scale factor. If you change the dimensions of a figure by a number, the perimeter will change by the same amount. Do you have any questions at this time about changes in perimeter? Let's take a look at how the area changes when you change the dimensions. If the dimension of a shape are multiplied by a number, which we call the scale factor, then the area will multiply by the same number, the scale factor squared. It's the old area times the scale factor squared equals the new area. Mathematically, it's the area times the scale factor squared, which equals area prime. Another way that you could look at this is if you have the area times the scale factor twice. Will give you the area of the prime or the area of the new. Remember, squaring a number means you multiply it to itself 2 times. Let's take a look at number 1. If each side length is multiplied by 2, the scale factor, then what will be the new area? I can multiply the area of the original, which is 5 times 4, and that is 20. Remember, you take the area of the old, multiply it by the scale factor squared. Therefore, I'm going to do 20 times 2 twice. 2 times 2 is 4. So I'm going to do 20 times 4, and it is 80. The area of the new shape will be 80 units squared. Again, I use the word units because they did not tell me if this is millimeters, centimeters, or inches. Let's see if you can do number 2 by yourself. Did you get 72 feet squared? You did have to find the area of the rectangle first. You have the length and the width of 4, so it's 2 times 4 equals 8. They gave you the scale factor of 3 because that is what the side lengths are being multiplied by. You have your original area times the scale factor squared. I broke it down into 8 times 3 times 3. 3 times 3 is 9. Therefore, 8 times 9 is 72 feet squared. Let's see if you can do number 3 by yourself. Did you get 405 feet squared? We did have to calculate the original area using 5 and 9 to get 45. The side lengths are being multiplied by 3, therefore my scale factor is 3. I would use the original area times the scale factor squared. I broke down 3 squared into 3 times 3, and 3 times 3 equals 9, therefore 45 times 9 equals 405 feet squared. Do you have any questions at this time? I would like to take a moment and go over an example of what it would look like if you were trying to find the new area if given a scale factor that is less than 1. So I'm going to turn my paper, and let's say that the original area equals 45, and the scale factor equals 1/3. I would like to determine the new area. I would like to determine a new area if given the area is 45 and the scale factor of 1/3. I'm still going to go through the same process. I'm still going to calculate the area of 4/5 times the scale factor, use 1/3, scale factor of 1/3 squared. It will be 45 times 1/3 times 1/3, which will equal 45 times 1/9. Because remember, you multiply across. 1 times 1 and 3 times 3. I know that I could do 45 over 1, or since it's multiplying by 1/9, I can do 45 divided by 9. So if I do 45 divided by 9 is going to give me a new area of 5. Again, I just wanted to make sure that you understood when you multiply by a scale factor of less than 1, the area is going to be going down as well. I will go over this again. You have the original area times the scale factor squared. I broke this apart into 1/3 times 1/3, and then I multiplied across and did 1/3 times 1/3 is 1/9. And remember, when you multiply by a fraction with a numerator of 1, you can just divide by the denominator and get your answer. Therefore, the new area would be 5. You may see a couple of examples like this on your homework tonight. Now let's take a look at finding the scale factor when you are given the new perimeter and the old perimeter. This looks awfully familiar. You still have the original at the bottom. Number 12. You can take the perimeter of the triangle is 10 inches after the enlargement. So apparently this is the old because it's after the enlargement the perimeter is 15. The enlargement is the new. What is the scale factor? And since I know that my enlargement, that it's an enlargement, I know that my scale factor has to be greater than 1. An enlargement means your scale factor is greater than 1. Your scale factor is the new over old. The new is 15. The old is 10. I can simplify 15 over 10 by 5 and get 3 halves. 3 halves convert to 1 and 1/2, or 1.5. Do you have any questions at this time? Let's see if you can do number 13 by yourself. Did you get 1/3 or 0.3 repeating? This one had a reduced scale factor, which means your scale factor is going to be less than 1. You put the new over the old. 8 over 24. I can simplify them both by 8 and I get 1/3 or 0.3 repeating. I would like to make a note down here that if you have an enlargement, you will have your new is larger than your old, and your scale factor will be greater than 1. If you have a reduction, your new will be smaller than your old, and your scale factor will be less than 1. Do you have any other questions about finding the new perimeter, finding the new area, or finding the scale factor?